classes, and my main job is to help you. So
Just letting it, we're recording now, by the way.
okay, so especially with the virtual, it's different for a lot of students. I'm here to help you with whatever problems there are, and actually there are some options for in-person coaching too. So if that's something you want to look at, let me know, and we can work something out. But I'll talk more about that later on after Bob gets rolling.
Okay.
Okay, so I know some emails come out.
How many students are in here? 10?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
11, okay.
2, 3. Wait a second. I can do this right now. Oh, 11.
11?
Yeah. 2, 3, 4, 6, 7, 8, 9, 10, 11. Okay, I got them all. Yeah, I know you got into serve mode. As long as I'm on camera, I can't do that.
Do what?
Oh, trying to minimize some things. There we go.
We can see both. I can see both you and your computer screen right now.
Well, I try and minimize certain things, and okay, people are popping big time now. Just to wait. Six. Jorgensen. 7. Buffy. 2, 4, 5, 6, 7. 2, 6. Need some more purchase. Okay, just give another minute or two for people to come on. We are recording the session as you're coming in. It's the only time you're going to see me. Otherwise, I usually on the camera for a couple of reasons. One, it takes up a lot of bandwidth, slows down the dial, slows down transmission, makes things a little jerky at times, and ultimately, I don't see a whole lot of value added. Just have to see me standing up here, since most of the time I've been working at the smartboard, and smartboard does not transmit very well. It gives you those little cascading images, so I'm going to avoid that. For example, actually not too bad. Like I said, to me that doesn't add a lot of value to it. Also, I just want to give one brief look at me. So you should have seen me in the hallway or anything. If by some chance you come on campus, at least you know who I am. So with that being said and done, I am going to kill my camera. How do I do that?
You have to go mouse up to the top of your screen. It should bring down a little menu. You got it.
It should be off now. Okay, good. So I should be seeing now is the as Blackboard. All right. Generally, the way this class is going to work is on class days, which is Monday, Tuesday, Wednesday, Thursdays, between the hours of 12:30 and let's pull up the syllabus real quick. So of course you want to find, if you ever lose a copy of it, put it on, you want to find it. Just go to Blackboard syllabus calendar. There's the syllabus right here. Should have gone to the page. And generally speaking, we'll be meeting between, you'll all be meeting here between 12:30 and 2:50. Although on Mondays and Wednesdays at what time, Nate? 1:45?
What about 1:45?
Okay. Mondays and Tuesdays, Nate is going to take over at 1:45 and follow through the rest of the class session. And he'll be here I'll let him discuss that.
Yeah, so I won't actually be giving you any new material. So Bob will be giving you everything that's new for the class. Bob's your really instructor, right? But I'll be covering some other topics that are supporting to intermediate algebra, some things that you might have forgotten about, or some things that really can slow you down with the new stuff that I want to make sure that we understand. We can also review some things that Bob goes over that might be a little bit, still foreign or things that we need to cover up on and take a little slower. So it's an extra hour of time just to reinforce this class because we are going so fast in 8 weeks. We've got a couple extra hours with me, your coach, to just go over some things and make sure that everything is solid so that when you do your homework, you feel more comfortable. And then your exam scores work out better and all that good stuff. So that's about it.
And you're really getting his additional service at no additional cost to you, so take advantage of it.
Yeah, we'll talk about any questions you have, anything you might say, hey, Bob went over this pretty fast. Can we go over this again? Absolutely. And that happens. I mean, that's Bob's job, is to go through this stuff kind of quick. we can slow it down.
So speaking of syllabus, syllabus, my phone number, my email, availability. I'm on campus a lot, but I also have a couple of classes going on. So if you want to actually have an actual appointment with me, which we can set up via WebEx here, but do shoot me an email or either via Starfish or an email or a phone message. Give me a day and some times that you're available. What I think I'll do is sometime this week I'll send out a matrix of times that I am not available, and of course pretty much everything between the 8 o'clock hour to late afternoon hours. If I don't have something booked or blocked off, I'm pretty much available to be able to get access to. So part of the workup will be for you to go through the syllabus. This is not your first time in the rodeo. A lot of this you've already seen if you have other classes before this one. But I do know sometimes this is some students' very first class. So it is worthwhile to kind of go through and check out your rights, responsibilities, specifically code of conduct, academic integrity, how to withdraw from a class or a program, etc. So if there's something blue, if it's blue, it's an active link to something. Technology-wise, you will not necessarily need a graphing calculator. If you have one, great. If you don't have one, don't go spending $100+ for one, because there is any graphing that you may need. I'll basically be using Desmos. There's also something out there that's very good called WabbitEmu. Just Google WabbitEmu, and it's a downloadable program. In fact, I got it right here. WabbitEmu that gives a super good fan video count. Well, basically gives you a TI-84 or an 83, depending on how you set it up. And if you're interested, I can try and send this via email files. This is what I use a lot. I'll be using this if I do any kind of calculator work. I'll be popping this up and doing it. It's a nice display. It works just like a calculator. It is a calculator. So typically we won't be needing a calculator, at least a graphing calculator. I plan on being here Monday through Thursday between the hours of 12:30 and roughly 3 o'clock, 4 o'clock, whatever the hours are. I will be here every day. I don't get sick, knock on wood. Even though this is a virtual classroom, attendance is required. I do take attendance, believe it or not. I have on the side of my, you can't see it, but I have it on the side of my screen, basically the participation list, and I see all your names up there. Now, there's being logged in and there's being logged in. So yes, I'm not requiring you to have your camera on. So yeah, technically you can log in and then walk away and sweep the floors or work on your car or whatever else. But that's not going to do you any good. I mean, you did sign up for the class, and this was originally a face-to-face. So I'm assuming you've already scheduled your day in life between the hours of 12:30 and 4:30-ish for the next 8 weeks on Monday through Wednesday, Thursday. So I'm expecting you to be here and listening and observing. Now, since it is virtual, if you do get COVID, but you're at home, hey, no loss. If you have COVID, you got to go to a hospital or go offline because of illness. Even not COVID, you get the flu, you get the cold, you get some other ailment. Same rules apply. Let me know, and so I know that you're having an excused absence, so to speak, for not being logged in. Oh, 11, another person logged in. Trying to figure who that person is. Different coaching, Nate's talked about that before. There's a lot of material, but not a lot of material. There's a lot of pre-work videos that I recommend be done before class. My MML videos, and I'll show you what those are and how they work. With the videos comes some homework. Okay, looks like a lot of homework, but hey, the homeworks typically have only about 10 problems in it. I've been playing with them already, and they go pretty quick. And we'll have 4 exams over the course of the semester. These are my math lab based exams. Again, done virtually. I'm not going to impose any kind of lockdown on your browsers. I'm not going to require a proctor. However, you will be having to sign a personal integrity statement for each exam, and the intent is your own personal work. That the person inputting the work is you. The person showing the work being done on the paper is you, and the person uploading it into the Dropbox is you, and we'll talk more about that later. A policy, these assignments have due dates, and at 15% of days, basically you have a 7-day partial credit window to get the work done. Breakdown on the work being done. For some of you, this may be the first time using my math lab. My math lab is picky at times. They ask for a very specific format of doing a problem entry, and if you do it wrong, it's going to come up wrong. However, if the program was looking for the answer 0.04 as a correct answer, and you put in 0.04, and my math app marked it wrong, don't worry about it. Every homework problem I look at, every test problem I look at, looking for those errors. So if you do a homework problem or an exam problem and it shows, hey, you got problem 5 wrong, but you know you got it right, give me a little bit of time to look at it. However, if it doesn't get corrected or overridden in a couple of days afterwards, then shoot me an email or during class, hey, Mr. Egger, homework 5.2, problem 7, can you look at it? Not a problem. Okay. Practice tests will be available, and it's pretty much okay in the calendar. Okay. Now I will be posting the active week in Blackboard, so whenever you go into Blackboard, the current week will pop up. The way you're going to read this is, hey, here's today, and basic stuff we're going to slam through is 1, 2, 1, 3, 1, 4, and tomorrow 2, 1, 2, 2, 2, 3. And the homework, the videos and the homework assignments will always be due on that Saturday. So the homeworks, for the most part, are due on Saturdays. So it gives you time to sit back, these Friday and Saturday, hopefully more quiet times than the rest of the week, to look at the problems. And yes, I said, don't be overwhelmed by the quantity of them, because like I said, they're only like 10 problems each. And for the most part, they're not multiple parts to them. So 10 problems are 10 problems. Looks like the exams I have scheduled will be pretty much like on Wednesday for the due date. And which the day before would be we'll schedule a review date for the exam, going over the type of problems and what to expect. And basically takes us out to the end, to the 8-week semester. Now, technically, the class ends here. I'm going to give you an extra day. I'll get the last test completed on it. Okay. So do look over the syllabus and the schedule. What the heck is this to? Go back for me? Yeah, it does. All right. And for the whole calendar. So you should pop in, whenever you come out of Blackboard, you should pop into the announcement section. And they always have the current week calendar up. Between now and next couple of days, you should look at how this class works. And a lot of information on it, a lot of boilerplating. But the big thing is, there is an assignment here. Your one and only discussion board for this class will be to introduce yourself, answer these questions for me, and the kicker though is you also need to look at 3 other people in the class and find something you have in common with 3 people in the class. So let's have the initial post, say by Saturday, and then like another week to get your another week to go in and do 3 posts on your other students, your fellow students, and of course submit it. Which one is the active one? Oh, here we go. I got a couple in there already. So we first need to fill it with everybody's initial response, and you go back in and pick 3 and make a discussion, or go back and discuss them. Yes, announcements, how this class works. Most of our time will be being spent in the learning plans. go. And one thing I need you all to do sooner than later is to basically click on this guy, my MATLAB browser check. And if you're logged in, this is what should pop up saying, hey, I checked your systems and everything was good. Let's see. And everything looks good, which is good. However, if you have not logged in before, we do have what's called inclusive access. So with your registration in this class, you were given a My MATLAB license. So all you should need to do learning plan is now click on any of these My MATLAB links, and it should come up with a window saying, I don't have a copy of page of one, unfortunately, but should just be giving you, should be asking you for an agreement. Hey, I agree to pick that little box that says you agree. No one reads these things anyway, so the fact that you're giving away your firstborn is irrelevant. But just check the I agree button, and that should give you access into all these here Blackboard items. My MATLABs will have that little, I don't know what you call it, spectacles, wire rimmed glasses laying on the side. I don't know. Anything like that, or oops, like that. That's a My MATLAB. That's My MATLAB. Okay. But each section has basically two My MATLAB assignments. One is a video and text. And they're videos, and they go quick. We're talking like 3 or 4 minutes of video. Okay, look at this guy here. Boom. And let's see what we have here. Okay, now that's 6.5 minutes. But these are videos that cover all the learning objectives. So again, if something I go through, if I went through something too fast in class, there's probably a video in that video section that'll cover the topic. That'll cover the topic. And of course, do the homework. I think I've already done it, so I can't do it again. Oh, no. Do the homework. Just click on it. It should take this window and just start doing it. So like I said, the 10 problems. Well, 7 to 10 problems. And notice there's only one part to this one. I said most of them are only one-part problems. Some may have 2 parts. Like I said, the amount of questions to answer are relatively quick. So even though maybe 5 or 6 sections to do, no, it's not too terribly large. Okay, come on. I really hate this thing. Go, new page. Okay. Another link you may want to know about is I sent you a link via email. I'm not going to do that again. Because on this menu is some kind of WebEx virtual classroom. So in the future, that's how you're going to get into it. And yours is going to look a little different than mine. So when you click on it, yeah, that's what I want. There we go. This one. It'll tell you which. It'll get you to a link that'll let you get into it then. So yours will look a little different than mine does because I'm the host. But that's the route you would take to get into the classrooms in the future, starting tomorrow. Let's see. Also have, again, on the same area, on the class material, Student My Math Lab. What's going on? My Math Lab, which are just a bunch of shortcuts. You want to just want to look at the home, just want to look at the assignments. So the homeworks. And it basically just show you the homeworks. Show all assignments. So again, it kind of shows you, it's going to show you when the due dates are. The 21st, yes. So when the due dates are on the left-hand column. And eventually when it starts, if you have overdue or past due, now it'll show up that also. It'll say past due. But remember, you got 7 days, roughly 7 days to get working late with deductions. So like I say, yeah. So again, if you don't want to go through the lesson plan, hey, you want to do 1.3, go to this page and just click on 1.3 and it takes you to that homework assignment. Again, so this class goes pretty quickly. Another one. After we arrange these guys, I go math, quiz and test. This My Math Lab multimedia library. It's pretty strong, has a lot of good things in it. Again, something to look at while you're doing this. Let's look at chapter 1. Okay. Select all, by now. Basically, these are all the assists you have. Some student success tips, which looks like those too big. Let's get rid of those guys. Huh. Look for. Okay, chapter 1 real numbers. You have again the videos, which are basically all these videos are what's going to be in the My Math Lab assignments for the video pre-work or pre-video assignments. But you also have animations for topics. Oh, that's enough. I stop this thing. There we go. So there's a lot of assets, a lot of good support we have in these with these Pearson. Another thing, let's go back to this one. E-text. Yeah. So you always have a textbook if all else fails. Then let's go to 1.3. And as you look at the text, there's a lot of active links here. So you may want to just play with. Hey, what does a globe mean? You know, let's click on it, see what it gives. Let's see what it does for us. It's going to give an example. What is the globe? Oh, what does this guy mean? What's this little arrow here? Oh, click on it, see what it gets you. Oh, it gets you to a video lecture on the subject. Okay. Uh-oh. There you go. Like I said, there's a lot of good stuff in here, and it's well worth your time to go through and take some time and play with them. All right. One thing I've got to show in the homework. To this guy. You're stuck on the problem. Instead of just spinning your wheels and grinding your teeth. Gee, I don't know how to do this one. Question help. Well, there's a video that'll help you. It'll take you to the textbook. This will send a direct link email to me. But video, and there's a video in a textbook to help you. This one here it has helped me solve this. There's a viewing example. Again, textbook, ask my instructor. So if you get stuck on a problem, go up to here to question help and see what resources that is provided to you to help you over the hump. So this My Math Lab has a lot of resources to help you be successful. Yeah. When in doubt, if there's a mistake, or if there's can't figure something out, or you go in and you try to an answer and you got it wrong. Okay, I know I did wrong. I just made a stupid mistake here. It should be 7. You get 3 tries. You get 3 tries. Okay. 23. I forgot the X. Yeah. Oh, okay. Then it's going to give you the correct answer. However, I got it wrong. I now know how to do it. Just do a similar question, and it'll replace it and do a similar question correctly. It will be logged in lieu of the error question. But you do it a couple times, you get the wrong answer. Okay, I guess maybe now I better go and do an example of how it's done. And I'll give you a step-by-step way of doing it, or how we solve it. However, if it helps you solve it, you won't get the credit for it. You're going to have to go and do it again. So there's a lot of help here for you. So student My Math Lab. Which is a great book. Or your My Math Lab great book. And it will just show you and of course you want your Blackboard grades. Ignore these dates. Don't know why they're not updating. we'll give you your what grade you got though. Okay. So my best recommendation is, hey, play with these links, and I got to clean this one up. This one I did not do. I don't take credit for this one. I'll claim we'll just have the relevant things needed for you. All right. That's basically navigating through my math lab. But the important thing is you got to keep yourself registered into it. And I see some of you have already. 1, 2, 3, 4, 5. So about half of you are registered, which is great. And again, the register, all you gotta do is, click on any link that has these glasses laying on the side. Any of these links, or go to learning plan as you're looking through it. Click on the browser check. It's going to bring you up to a page where it's going to ask for you to accept the terms of licensing, terms and conditions. And that's all you should have to do. If that's not working, you need to contact me. Yeah, let's see what we got here. All right. Half an hour, and I got, about 40 some odd minutes to do my spiel. All right, so today, one, 2, 1, 3, 1, 4. So I've already looked at these the assignments for this one. They're pretty basic. Practice tests down the bottom for chapter 1. Okay, practice tests on the bottom. These practice tests, they're not graded. They're just for your own purposes, for your own uses. So because of the short day and the pace of the class, that's the last. I won't catch it. I was planning on just kind of going over a lot of what I think are the major hiccups. Okay. And like I said, I'm no specific order of 1, 2, 1, 3, 1, 4, which are sets, real numbers, and algebraic expressions.
Hey Bob, this is Nate. I noticed a couple people said the syllabus is not there, and it looks like the syllabus is still not available. If you want, I can do my best to turn it on for them.
Syllabus isn't available? How's that?
It's available for you, but if you turn your edit mode off, you'll see it'll disappear.
Oh, shoot. How the heck did that happen?
That's okay. Too many I's to dot and too many T's to cross. Now you should be able to get the syllabus. They were just hidden.
I probably should put the chat. Oh, yeah. I'm sorry. I was on the physical class state moving online.
And that's good. Thanks, students, for letting us know. If you have any trouble like that, let us know.
Yeah, I usually have the chat up on the side, but I just got to do it today.
Yeah, it's a lot to manage, so it's all good. All right, Lewis sees it now. Good.
Everyone sees it. Good. All right. So I'm gonna make some assumption that there are some things that are pretty much already well known. Okay, or not between the help links in the problems and reading the book will catch them all. Okay, but things you got to realize that there's two big things we're looking at in terms of numbers: rational and irrational numbers. Okay. Sounds pretty easy, pretty basic. But for a rational number, we basically have two things that have to happen. Well, actually, not one thing. A rational number is a number you can describe as basically an integer numerator over an integer denominator. Two whole numbers, somehow I can describe something as two whole numbers. Such as, well, 12. Plus 12 minus 12. But you may say, hey, that's just a numerator. Ah, but is it? Okay. I'm saying this covers that rational number definition because I can always write a whole number as 12 over 1. Now that fits my definition of a numerator integer over denominator integer. Or how about 24 over 2, which is also 12. Again, an integer numerator over an integer denominator. And it's pretty much any, and if I can take any number given to me and do that, it's a rational number. But be careful, because someone may think, oh, what about this number? How about 0.1111 dot dot dot? Goes on forever. I can't write it as a decimal, as a definite decimal. Therefore, it must be irrational. Well, no, because not in this class, but in other classes later on, you're going to learn that, hey, this guy is basically 1 over 9, which is a numerator integer divided by a integer denominator. So just because it's one of those forever type numbers does not necessarily make it irrational. The main key is for a rational number, I need to be able to describe it as an integer numerator over integer denominator. Of course, then that means irrational must be everything else. Now, what's per example an irrational number? Well, pi, 3.1415, blah 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 blah. Oh, hey, there's those dots. But the first one, I was able to rewrite as 1 over 9. Pi, they have yet to find a number, a numerator divided by denominator, an integer number that will give me pi, that will approximate that number. Other rational numbers, so that's one of them. Another one is a lot of your roots. If it's not a perfectly square root, 2 is not. Four is. Square root of 4 is 2 times 2. So square root of 4 is a root, but it's rational. Square root of 2 there we go again. Is not. Square root of 2 is irrational. So we got two main families, rational and irrational, and thing with rational numbers, numerator, denominator, integer numbers, irrational. The best I can do is approximate it to a decimal, however many decimal places you want to go out. Okay. One of those interesting things. Absolute values, or correction, inequalities. If I was to ask to number 4 and 5, which one is, what would I use my inequality? Would I use this guy, that guy, or that guy? I would say every one of you, not a person on here in this class would not do that. Of course, if I do it the other way around, I don't think there's a single person in this class that would not get that one right. Well, the buzzword, the key is it should always be pointing towards a smaller number, opening to the larger. Now, when some issues come in or some questions come in is, what about when it's like that? On this one, I would suspect there'd be one or two people that would get it wrong. There's another way of looking at the inequalities is not just which one's bigger, which one's smaller. The question you ask you is which one is less negative? Or which one is more closer to the positive side? So the less negative or more positive would be the bigger one. So in this case, I'd have it pointing to the -5. And of course, the other way around, then pointing to open it, the more positive, pointing to more negative is that one. Another way of, and that's a little mind-blowing for you, think of a number line. Think of a number line. Three, 1, 2, 3, 4, 5. -1, -2, -3, -4. All right. On a number line, going left to right, negative to positive, okay. Let's say what this one looks like. This here base is going to point, base point to more negative. And this time we're going to say smaller. In that case, between 4 and 5, point to the 4. Between -4 and -5 here, again, point to the left, which is basically how this guy and that guy looks. So you can also think of it as, again, just a direction. Okay. Again, I'm going to say, I'm not concerned about that one. I don't think I've ever gotten anybody get that type of problem wrong. However, difficulties do come in with the second one when I start talking about negative number, two negatives. And the really difficult points are when there's like a, again, negative. Gee, which one's smaller? Which one's more negative? Which one's more positive? And if you look at the number line, well, let's blow it up. So maybe like here's like negative. Here's negative 3.1. Here's negative 3.01. And somewhere out here is 0. So between which one would be more negative? Which one would be smaller? I think everyone's going to agree that that's the more to the left. That's the inequality. Use that guy. So, gotta be careful. There's a lot of little nuances in this section. Fractions. Adding, subtracting. The golden rule for adding, subtracting. Now, if we're in person, I call for a shout out, but I'm not going to do that. But for adding, subtracting fractions, there's one golden rule for adding, subtracting fractions. Gotta have common denominator. That's the golden rule. Just remember that, it should all fall in place. I can have mixed numbers. I can, now let's just do an easy one. Let's 5/6 plus 7/18. I'll tell you what it's not. It is not 12/24. Okay. It is not 12. We do not add numerators. We do not add denominators. Okay. Because you need a common denominator. So between 18 and 6, we got to find the multiple that they both share. And pretty much went in bed, everyone is screaming at the top of their mental lungs, 18, 18, 18. Yeah, 18. Of course, how do we make a 6 into an 18? Multiply by 3. Of course, the law of equality is, at least in fraction, whatever you do to one part of the fraction, you must do to the other part. So I triple my denominator, I need to triple my numerator. Because 3/3 is 1, right? Well, this becomes a 15/18 plus 7/18. Not 36. Not 36. 18. Okay. Set it and forget it. Then we add numerator, which is what, 22, I think. Yeah. And of course, hey, both are even numbers, so I can at least get 2 out of them. So if I yank out the 2 from 22, this reduces down to 11/9. 11/9. That's an improper fraction. Top bigger than bottom. There's an improper fraction. I turn it into a mixed number. Of course, how many 9s can I get out of 11? I can get 1 set of 9s. And leftovers. One times 9 is 9, and 9 plus 2 is 11. And same with subtracting. I'm trying to subtract do mixed numbers. 1 7/8 minus, let's make that plus again. Plus 2 4/5. That's fine. I can do that. All I gotta do is, hey, it's technically 1 7/8 is really 1 plus 7/8. 2 4/5 is really 2 plus 4/5. That's why I say 1 7/8. The and has a grammatical correctness of being addition. So 1 7/8, 1 plus 7/8. So I can add my whole numbers, 1 plus 2. And then again, I have my fractions, 7/8 and 4/5. Again, common denominator. What number does 8 and 5 share in common? Well, 5 is a prime number. Because 5 times 1, 8's 2 times 4, 8 times 1. So base is going to be 40. That's 5. 8 times 5 is 40. got 7 times 5, which is 35. 4 times 8, which is 32. For now we have 3 and 67 over 40. And how many times can 40 go into 67? 1 time. So since 67 is really 1 and some fraction, 1 plus 3 is 4. And 67 minus 40 would be 27. And what I want to do. All right. So again, come on. You follow that? Don't lose track of that rule. You will have no problem doing fractions. Adding, subtracting. A fraction multiplying and dividing, it too has a golden rule. Always use fractions. Never use mixed numbers. Never use mixed numbers when multiplying and dividing. Always turn them into a fraction. If it's a mixed number, it'd be improper. For instance, that should be common, by the way. For instance, 3 and 2/5 times 1 and 4/7. Doesn't matter. What it's not going to be is 3 times 1, and then 2 times 4 is 8. It won't be that. We can't, unlike when we add and subtract, we can add and subtract the numerators of the whole numbers, and then add and subtract the fractions with the common denominator. With the multiplication division, we can't do that. Won't work. And if you think about it, I mean, I'm starting with something bigger than 3. I'm multiplying by more than 1. I should get a number bigger than when I started. And 3 and 8/35 doesn't seem to fit the bill there. So we got to go to an improper fraction. Means my denominator is not going to change. What we're going to do is multiply the whole number by the denominator, 3 times 5. That'll turn 3 into the improper fraction of 3, turn into fifths. And then we'll add the existing numerator. Same thing here. I'll multiply the whole number by the denominator. And I'll add the existing numerator. 2 times 15 is 3 times 5 is 15. 15 plus 2 is 17. So 17/5. 1 times 7 is 7. 7 plus 4 is 11. And now I can multiply. Now I do multiply my denominators. We will multiply denominators. 7 and 17 times 11. For 17 times 11 would be 187. Yeah, 187. And 5 times 7 is 35. Of course, that's an improper fraction. My math lab will let you know. Always read the fine print on the My Math Lab problems. Read the blue underneath the answer section. It'll tell you how it wants to answer. Give the answer in 4 decimal places. Give your answer the nearest hundredths, 2 decimal places. Give your answer reduced. Give your answer as a mixed number. It'll be that specific. And how many times does 35 go to 187? Oh boy. I guess we need to do a little bit of math. Some integer math. 2 times 35 is 70. So that means 4 would be 140. It's 5 times. 5 times 5 is 25, 32. 5 times 3 is 15, plus 2 is 17. So it'll be 5. And what over 35? Now, let's do subtraction here. 7 minus 5 is 2. 8 minus 7 is 1. So 12/35. So, which is a whole lot different than that. Division, same general rules. The only extra thing I know of division. I think I remember division is, yes, it needs to be in fractional form only. No whole numbers allowed. Fractional forms only. And is to change it into a multiplication problem by taking the reciprocal. Just means flipping the positions. Numerator comes denominator, now becomes numerator. It's just do the reciprocal. Of course, try and find any kind of reduction you can do. And of course, that'd be 1 and 1/4 then. So if I have 5, 6, how many times can I take 2/3 into it? Which is 4, 6. Oh, okay. So 1, 2, 3, 4, 5, 6. All right. So here we have 5, 6. And here we have 2/3. So 5, 6. Now by 2/3. Does that make sense? Yeah. Inside 5, 6 is 1 whole 2/3 size dimensions. And let's see, how does this axis compare to within 2/3? Wow, this little circle, I can do 4 times. 1, 2, 3, 4 times. So that little bit represents 1/4 of 2/3. So 1 and 1/4. Visually, graphically, it makes perfect sense. But don't kill yourself trying to do that. Division. Like multiplication, I want all fractions. Go from division multiplication by taking the reciprocal of the second number. But you all knew that already. So quick review on fractional math. Okay. And like I said, I'll be saving these files and I'll be posting them in Blackboard also. This is being recorded, so you can also put things side by side. All right, another major stumbling block that I've seen time after time is the difference between this and that. Pretty much everyone is familiar with what an exponent means. Now, I have some number cubed. That just means a times a times a multiplied 3 times. But you got to realize the exponent is very, very narrow sight. The exponent is glues itself to the nearest number or nearest variable. So this exponent here is glued to the 4. The negative isn't part of the exponent expression. So this guy translates to minus 4 times 4, which is not a positive number. Be a negative 1. Now this 2 is glued to the parentheses. And what's inside the parentheses is what gets squared. So what the exponent sees is, that's what the exponent sees. I see parentheses. So I'm going to take those parentheses and I'll double them. Or it's 3 times 4, 4 times. But what's in the parentheses? Now I multiply 2 negative numbers. Of course, 2 negative numbers multiplied gives me a positive 16. That is a landmine that gets stepped on very often. And sometimes they do it very sneakingly. Like, we'll give you this, minus 3y squared, and evaluate it at, well, let's do it 2 ways. At y equals 2. That's just plug and play. Hey, I got a value for y. I've got a location to shove that into it. So this becomes minus 3 times 2 squared. Again, look at what the 2. The 2 is only doing the y and the 2 there. It's not doing the 3, and it's definitely not doing the negative number. So 2 times 2 is 4. 4 times minus 3 is minus 12. And what about at y equals minus 2? Okay. Now, the 2 is attached to the y. So basically, it's y times y. Means minus 3 times minus 2 times minus 2. Of course, those 2, I'm cutting like minus 2, that's minus 2. Just like before, that'd be a positive 4. So minus 12. Come on. This means I could have written this as minus 3 times minus 2 squared. Where all of that basically is, with the parentheses, is y. So that y being squared is with parentheses. Okay. So exponents and negative numbers can sometimes get a little screwy. Do 5 minutes. All right. Order of operations. Love it or hate it. Everyone's heard, please excuse my dear Aunt Sally. Okay, that's good. PEMDAS. Okay. Parentheses, exponents, multiplication, division, addition, subtraction. With multiplication left to right, and subtracting left to right. Okay. A lot of people sometimes, the left to right rule gets a lot of people. 4 divided by 4 times 4. No parentheses, straight run there. If you just go on, hey, you know what? Multiplication before division. So I'll multiply first. Now divide, which is basically 1/4. Of course, that would be wrong. You always keep the left or right rule in mind. Oh, not right. Left or right. Left to right has us at, well, 4 divided by 4 is 1 times 4, which is 4. Because another way of writing this guy is 4 divided by 4 times 4. Now, if I gave the problem that way, you'd have no problem with it. Hey, I got a fraction, 4 over 4. I reduce it to 1. Then I multiply by 4. And I get 4. That's reading left. That's what reading left to right does for you. Puts the values in the proper order, so to speak. And of course, if I really wanted this guy, what I needed is 4 divided by. Now that's 1/4. Because order of operations says do parentheses first. I have parentheses. Which is 1/4. Well, 4 was 16, reduced to 1/4. All right. So left to right is very important to have kept in mind. So let's try one of these real quick. Let's look at all right. So again, so any of these problems, hey, first thing, look at, do I have parentheses? Yes, I do. I have parentheses where I have minus 8 plus 5. Let me show you a cheat here. Then I have to use a calculator for this stuff. Minus 8 plus 5. Okay. I'm looking at it, I see absolutely 8 is bigger than 5. I know 8 is bigger than 5, which means right away I know the answer is going to be negative. But negative, how much though? Now, this is when I sidebar, okay? Minus 8 plus 5 is going to have the same magnitude as switch the signs. Make the 8 positive, make the 5 negative. So now we're subtracting a smaller number from a bigger number. That's much more natural, much more safe feeling. That's a 3. But because I did a little bit of time to do a general magnitude sign check, because the bigger number is negative, the answer's got to be negative. Well, negative by how much? That's that little thing on the side by switching the numbers. So minus 3. Okay. So now minus 8 plus 5 is minus 3 times minus 2 squared. Minus 3 minus 3. Okay. Now I didn't do the minus 2 quite yet. Yeah, let's do that. Ah, crap. That was weird. So that's going to be minus 3. And the other parentheses was minus 2 squared. All right. Look what that 2 is. That 2 is inside the parentheses, not outside. It's inside. Which means that 2 is only seeing that 2, not the negative. So it's still only minus 2 times 2, or minus 4. Okay. Next step. Okay, let's look at the numerator and denominator. Now, we're going to look separately. So the numerator, I got no more parentheses, but now I'm going to look at the numerators and denominator separately. The numerator is 2 numbers multiplied. The denominator is 2 numbers being subtracted. Okay. So we'll do that. Minus 3 times minus 4, negative times negative, is a positive 12. Negative 3, I'm going 3 more to the left, more negative, minus 6. And last, I guess the answer is minus 2 then, when you reduce. That's the right answer. Is that right? Yep, minus 2. Okay. Then a quick review on a lot of topics, range from inequalities to fractional math to types of numbers out there. And I see I'm going in. I am in Nate's time now, so I'm going to back out and figure out how to
Make me host?
Yeah.
Okay.
I knew how to do this a second ago.
Well, while you're doing that, do you mind if I kind of take over?
Yeah, go ahead.
All right, I'll share my screen here. So, which screen do I want to share? I'll share the screen here.
Ooh. Oh, here we go. It's down here.
Nope. So for those of you that came in maybe just a little bit late, Bob is your instructor. Bob went through the syllabus, and we're still recording, right, Bob? So I'll stop that when we're done. But
Yes.
I'm Nate, and I'm going to get ready because I'm going to ask you to introduce yourselves in a few minutes here. I want to hear your voice. And so my name is Nate. I'm an academic coach, so I won't be actually grading any homework or tests, but I'll be another resource for you. This class does move pretty fast. So the group that I worked with the first 8 weeks actually liked the 8 weeks because the class did go fast and it was done much quicker than before you knew it, it was almost over. But you do have to keep up. You do have to do the homework. That's the best way to pass this class. Just keep up with the homework. If you're struggling, if you're looking at it and you're like, I don't know what the heck this is, well, that's where I come in. On Blackboard, and here, can you all see my Blackboard? And feel free at any time you can privately chat me or chat or unmic yourself. So you can always send me a chat privately. If you can't see my screen, let me know. But this is your Blackboard shell, right? And the syllabus is what Bob was talking about was here. I want to show you under resources, there's a landing page called academic coaching. So if you pick that, if for whatever reason you're struggling, you're just frustrated, don't know what to do, need help, Bob went too fast, blah, blah, blah. This is where you can get help. Number of resources, and you use whatever works best for you. In addition to making an appointment with Bob during his office hours, you can also work with our coaches. So the first thing I want to point out is we have a virtual math lab. And I'm wondering, has anybody used the virtual math lab before? I'm not sure if you're all new here or not, but if you've used it before, let me know in the chat or unmic yourself or mute yourself. If I pick on this virtual math lab, it'll open the schedule. So this is intermediate algebra, so just algebra. So Wednesday, so right now from 10 a.m. to 5:30, we've got an assistant coach in there. Right now, I believe his name is Bruce. If I were to click on this, it would bring me right into the Blackboard Collaborate, which is very similar to WebEx. I type my name here, I hit join session, it'll bring me right in. I'm not going to go in right now, but that's how we do it. Any questions on that? So that's drop in. You can drop in there for 2 minutes for a quick question. Some students will do their homework while they're logged in there, and that you can get help with every question if you want. They can work you through it. They won't do your homework for you, but they'll ask you questions to get you thinking and help you, make sure you understand what's going on. Because we want you to do your homework and just be done with this class. The next thing is in person. There's not as much in person because of COVID, but you can sign up. So click on COVID or the in person. So like on Thursdays, there is some time on Thursday afternoons. So you would sign up for a time that works for you. So it looks like Thursday and Tuesdays, there's some sign up for in person. So if you really want to be in person, we do have in person. We have to wear masks and everything else. So there's in person there for those that really want to be in person. And then we've got 2 academic coaches. We've got Shane and we've got myself. So if you click either one of these 2 links, that'll bring you into our calendars in Starfish, and you can make an appointment with us during our office hours. So a lot of students like to do that. They like to work with me or Shane, and either one of us will work with you. And if you want to learn more about me, you can click this little link here. It's kind of hiding, and you can read about my background in Starfish and everything else. So any questions on any of that? As I mentioned, my name is Nate. I'm actually an academic coach. I was an engineer for about 10 years, and then I decided to go into education. So I landed here at NWTC about 8 years ago. And now I love helping students. I work with chemistry students and physics students and math students. But I think some of you are actually in the sonography program, which you will have to take physics. I think some others are in the engineering program. So this is going to be a heavy hitting course for you. So I just want to go through the list and ask you what your name is, what your program is, and then I want to ask you what your favorite breakfast food is. So my favorite breakfast food is French toast, and either French toast or pancakes with lots of syrup, brown sugar, and big tall glass of chocolate milk. So I'm going to go down the list here and just tell me your name, your program, and favorite breakfast. So Bryce, are you there?
I sure am. Yeah, the gen eds transfer to UWO.
Okay.
And then, what was the other question? I forgot.
Favorite breakfast.
Oh, I like bacon, egg, and cheese on a toasted bagel.
That sounds good.
Yeah.
Awesome.
Cool.
Thanks, Bryce. And yeah, I like breakfast a lot. Sometimes I eat breakfast for lunch and dinner as well. So, Carson, are you there?
Yep, I'm here.
What's your program and your favorite breakfast?
I'm doing the general ed study transfer, and I'm going to be going to UW Stout for engineering.
Awesome.
And then my favorite breakfast is biscuits and gravy.
Okay. I hear that a lot from students, biscuits and gravy. I've never had that, but I'll have to try it. Excellent. Evan.
What kind of engineering were you in?
Oh, good question. I was a mechanical engineer. I graduated from UW-Madison in the 90s, and I was a mechanical engineer. And it's kind of a really diverse field. You can go into design or manufacturing. I was a design engineer. I worked for a company called Plexus that's in Neenah, Wisconsin.
Oh, yeah. My mom's fiance works there.
Okay, cool. Yeah, I worked there for about 7 years, and I moved around. I just really like the math. I'm really weird that way. I missed doing the math, and so I really kind of found my passion for helping people like you get there. So if you want any other discussions about engineering, feel free to reach out. I'm happy to answer any questions that you have.
Awesome, thank you.
Yep, good question. Evan, are you there?
Yeah, I'm here.
Program and breakfast?
I'm in the general studies program, transferring to UW Green Bay.
Okay.
And my favorite breakfast is probably a bagel with cream cheese.
Okay. Those are good too. Those are good. Excellent. Grace? DeWeert?
Hi, I'm just doing the general studies transfer to UWGB, and favorite breakfast would be coffee and pancakes, probably.
That sounds good to me. With syrup, I'm assuming.
Mm-hmm.
Awesome. Yeah, I like pancakes. I gotta make pancakes more often.
Mm-hmm.
Good. Izel or Ezel? Ramirez?
Yep. Hi, I'm doing the general studies program to GV.
Yep.
And I like hash browns and coffee.
Okay. Yeah. I always get a few people that like hash browns and I hate them. So if I ever see you out for breakfast, you can have my hash browns. Excellent. And did I say your name correctly? Is it Izel or Ezel?
It's Ezel.
Ezel. Okay, I'll do my best to remember that. Ezel. Jace Warrington, are you there?
Yep, I'm here.
Program and breakfast?
I'm just doing general studies at the moment, and breakfast would probably either be cinnamon toast crunch or hash. Corned beef hash is really good.
Oh, I never had that before.
You're missing out, man. It's delicious.
I'm gonna have to try it. I'll take your word for it. I'll have to try it. Cinnamon toast crunch, I used to eat a lot. I used to be a big cereal eater. But yeah, that's good stuff. Excellent.
Oh, sure. Thank you.
Yep, thank you. Joseph Duffy? Are you there?
Yes, I am here.
All right. Program and breakfast?
I'm just in a general studies transfer. Don't know where I'm going to go yet.
Okay.
And for breakfast, I just normally eat like Pop-Tarts or cereal.
Okay. I was a big Pop-Tart guy in college too. Excellent. And okay, Luis Herrera?
Hi, hello.
Program and breakfast?
General transfer studies to Green Bay, UWGB, and for breakfast, at the moment, it's currently all Count Chocula.
All called Chocula. Does that make the chocolate milk afterwards?
Yep.
Yep, I used to eat that a lot too. That was good stuff as a kid. I used to eat that a lot.
Oh, yeah.
Excellent. Great. Madeline Jorgensen?
Yeah, I'm doing the general studies transfer to UW Milwaukee.
Okay.
And for breakfast, probably like a breakfast sandwich or a breakfast burrito.
Okay. Very good. A lot of transfers here. And last but not least is Presley Kreisman. Hey, Presley, are you there? I can see you're unmuted, but I can't hear you. I don't know if your microphone's working or not. Yeah, I'm not hearing you at all. There you go.
Okay. Yeah, I'm doing the general studies transfer to GB.
Okay.
And for breakfast, just cereal or yogurt and some orange juice.
All right, sounds good. Well, that's it. That's it for people that are logged in. So welcome everybody. I do want to point out there's a lot of transfers here, and nobody really mentioned what their career goal is, and I know some people don't really know, and that's okay. But I just want to put a plug in. We do have a career services at NWTC, and so if you're still exploring what you want to do, feel free to engage with them. They've got some quizzes and some things that you can take to kind of figure out what you might be good at, and what you might like. Because I think if you find a job that you're good at, that you're talented at, and you like, that you have some passion about, that's going to really be a key to be happy. And if you're happy, you're going to work harder, and that just makes life a lot easier. That's why I'm doing what I'm doing. I wasn't really happy as an engineer. I wasn't really scratching my itch, so to speak. And for me, being a math educator really is passion to me. And I think Bob didn't say it, but Bob was also an engineer. I think he was, I don't know if he's still on anymore, but he was, I believe he was a mechanical engineer as well. But yeah. Did I get that right, Bob?
Yeah, it's a pump kicker.
Pump kicker? Okay.
It rotates, hit it hard, it'll break it loose. Mechanical.
There you go. Bob, fun fact about Bob, he also drove submarines in the Navy, so he's one of those guys that can spend a lot of time underwater. So welcome everybody, and again, if you ever want any help about trying to decide what you want to do with life, let me know. I'd love to help you find that out, because if you know what you want to do, if you have a goal that just makes you a little bit more passionate and goal-oriented and makes you want to get through the stuff. So what I want to do next is I want to just do something fun. Have you ever played a Kahoot before?
Yeah.
I'm going to
Yes.
Let's do it. Let's do a little Kahoot for fun. And I don't think you can. I'm going to actually reshare my screen here, because I think I can. Give me a minute. I'm going to reshare my screen here. I think I can actually make it so we can hear the music. Because music is part of the fun. So I'll give you a minute to join, and you can put in whatever you want. So if you haven't played this game, you're going to want to go to Kahoot. So you want to go take your phone or your device and go to www.kahoot.it. Or if you have the Kahoot app, and then it'll ask you for this game pin. So you put that pin in, and then it'll ask you for a name. You can put in your name, or you can put in a nickname or whatever you want. Some people use icons and emojis. So we should have about 10 people. So I'll wait till we see about 10 people in here. And if you haven't played, the answers are all anonymous. I mean, you can kind of see who's on top, who's winning, but if you get a wrong answer, you're not going to know who got the wrong answer. So this is just for fun. 2, 3, 4, 5, 6, 7, 8, 9. One more person, I think, we're waiting for. 2, 3, 4, 7. As that 10th person is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're all here. So Bob went over common denominators a little bit in fractions today. So I want to revisit that and just see what your comfort level is with that, because that's one thing that's not going to go away for this class. Fractions is sometimes a big stumbling block for a lot of people. But I just want to make sure we're kind of comfortable. I'm going to turn the music back on here. All right, so let's see what we know. What is the least common denominator of 2 and 5? most of you got it. So I want to just point out, and I think most of you got it, but this number least here can be kind of misleading. We're not looking for the smallest of the two. We're looking for what's the smallest number that divides by both 2 and 5, basically. In this case, 10. 10 is the smallest number that divides both by 5 and by 2. So identifying least common denominators, or least common multiples in this case, which is the same thing, is going to be critical in this class. We're going to work on that still. And I don't have any prizes, I'm sorry, but what is the least common multiple of these three numbers? Again, what's the smallest number that divides by all three of those numbers? So 2, 3, and 4. So yeah, 12 is the smallest number. So 6 divides by 2 and 3, but 6 does not divide by 4, right? 6 divided by 4 gives us a decimal, and we don't want that. 2 is the smallest denominator, or smallest of those numbers, but we're not looking for the smallest of those numbers. We're looking for what is the least common multiple. So the multiples of 2 are 2, 4, 6, 8, 10, 12. Multiples of 3 are 3, 6, 9, 12. And the multiples of 4 are 4, 8, and 12. And so 12 is the smallest number that shows up in those lists. So I just want to see where people are at, that's all. So for these two fractions, what is the least common denominator? Same idea we were just looking at. 1/3 and 5/6. So we still got a couple people that are still a little bit, still struggling a little bit. But can someone tell me, anybody comfortable? How do you know it's 6? Why is it 6?
Because 3 can go into 6.
Yeah, so we know that 6 actually divides by 3, right? 6 divided by 3 is 2, and 6 divided by 6 is 1. So a lot of times the least common denominator can be one of these two denominators, but it will probably never be the actual smallest one. So the least common denominator is going to be at least as big as the biggest one, if not bigger. So I want to see, Maddie's on fire here. What about these three? Now think about what's the smallest number that divides by all three of those numbers, 3, the 4, and the 6. So here again, so 12 is the right answer. 12 divides by 3, 12 divides by 4, and 12 divides by 6. 6 divides by 6 and 3, but 6 again does not divide by 4, so we know 6 can't be it. So 12 is it in this case. So where are we for standings here? Okay, 5. What is the least common denominator for these two guys? This one is challenging, and you might not know this one. Okay, how in the heck did you know it was 60? Does somebody want to say how they knew that? Did they just know it from the past, or?
Yeah, it was just I knew that 12 and 15 both went into 60.
Yeah, and some people don't realize that. But what I do want to take a pause here. I want to show you something kind of quick here. I do want to show you something. Those of you who might not, I don't know if most people got it, but I do want to show you something if you don't mind me. What page is this on here? This is a study guide, by the way, and I'll show you where this is in the Blackboard if you ever want to reference it. So there's a couple examples here on how to find the least common denominator for two numbers like that. And so I'm going to take my pen here. And so in this example, we have 8ths, 7/10, and 1/12. And basically, one thing you can always do is take each one of those denominators and break them down into their prime factors. So 8 is 2 times 2 times 2. 10 is 2 times 5. 12 is 2 times 6, and 6 is 2 times 3. So here we go. This is 12 is 2 times 3. And now I want to make them all the same. So this 8 has 3 2s, so they all have to have 3 2s. So I'm going to give this guy 2 more 2s, and this guy 1 more 2, so they all have 2 3s. Or I'm sorry, 3 2s. 12 has a 3, so I'm going to give this guy a 3 and this guy a 3, so they all have 1 3. And 10 has a 5, so I'm going to give this guy a 5 and this guy a 5. Now they all have the same numbers. So if we multiply those together, we've got 2 times 2 times 2, which is 8, times 3, which is 24, and 24 times 5. Actually, did I do that right? Yeah. So in this case, I'm going to do it a little differently. 2 times 5 is 10. 10 times 3 is 30. Times 2 is 60. Times 2 is 120. So in our example, we had 12 and 15. So 12 is 2 and 6, and 2 and 3, and 15 is 3 and 5. Oops, darn it. So now I have 12 is 2 times 2 times 3, and 15 is 3 times 5. So because 12 has 2 2s, I need to give this guy 2 2s. And they both have a 3 already, but this guy needs a 5. And now they're the same. So 2 times 5 is 10, times 3 is 30, times 2 is 60. If that makes sense to you, that's a technique you can use for any common denominator. And we'll start using this later on in the course, probably around week 5 or so. If that's something that you're still not sure about, you can practice this on your own, or you can give me a call or make an appointment with me or let me know, and I'll be happy to work with you until you do get it. But I just want to show you that little technique and where this came from. So back to Kahoot. How confident are you? Really confident, somewhat confident. So if you're not really confident, I want you to let me know outside of this class if we don't cover it up today. I don't know who you are. I'm not going to ask you in class, but please let me know. Send me a message, send me a note, and I'll show you how to do that a little later. And I'd be happy to work with you on that. We'll spend a little bit more time today doing that as well. After this quiz here. So do you remember how to multiply fractions? Okay, that's what I thought. Could use a refresher. We'll do that today as well. Actually, starting right now. What is 2/5 times 2/3? So multiplying fractions, All you have to do, can I write on here? No, I can't. All we have to do is multiply the top numbers, which are numerators, and the denominators. So let me bring up let me add a blank page here. I'll write it right here. So I have some blank space here. So what was our two fractions? 2/5 and 2/3. So 2/5 times 2/3. Multiplying fractions is kind of easy. We're going to multiply the two top numbers together. 2 times 2 is 4. And the two bottom numbers we multiply together. 5 times 3 is 15. So that's multiplying fractions. I actually like multiplying fractions a lot more than I do adding, subtracting, which are over here, because we do not need, oh, I can't spell today, need an LCD to multiply. We don't need an LCD to multiply. We just multiply the two top numbers and the two bottom numbers, and that's our answer. And was that our answer for this? It was 4/15. So multiplying should be fairly easy. Let's do a little bit more. What about this one? 1/2 times 2/3. I thought I'd catch some of you on this one. Yes. So those of you who put 2/6, you followed my advice, right? You just multiply two top numbers. 1 times 2 is 2, and two bottom numbers, 2 times 3 is 6, which is really, not wrong. But can someone tell me why the red 1/3 is really the correct answer here? Does anybody know? Half and 2/3. Simplify. Yeah, someone chatted that they have to simplify. Yeah. Yeah, so we have, what was that fraction again? So this will happen on homework a lot too, so be careful. This is one of those habits that when we're taking a math class, we have to kind of get in the habit of, is reducing. So we have 1/2 times 2/3, I think it was. Now I did say to just multiply the tops, right? So 1 times 2 gives us 2, and 2 times 3 gives us 6. Now, when I get to this point, I always ask myself, can I divide the top and the bottom by the same thing? In a fraction, we can, if we multiply or divide the top and the bottom by the same number, we get what's called an equivalent fraction. So it turns out I can divide both the top and the bottom by 2. 2 divided by 2 gives me a 1. 6 divided by 2 gives me a 3. This is called reducing. Another example might be, I'll write it over here. What about the 5/15? Can we reduce that? Both 5 and 15 both divide by 5, right? 5 divided by 5 is 1. 15 divided by 5 is 3 as well. What about 14 over 21? I'm thinking, do 14 and 21 both divide by the same thing? And if you're a little rusty, It might be hard to see, but both 14 and 21, they both divide by 7. Fourteen divided by 7 is 2. 21 divided by 7 is 3. So this is all called reducing. And when you come up with an answer, whether it's fractions or something else along the way in this class, whenever you get a fraction for an answer, the computer homework is going to be looking for the reduced answer. On a test, I think Bob will be probably a little bit more forgiving, but again, he might take off points if you don't reduce the final answer. But here's the thing, when we're multiplying fractions, there's something we can do before we get to the final answer that will help us reduce it. That's our original problem, 1/2 times 2/3. We can actually cross reduce, which means I'm going to look at the tops and the bottoms and ask myself, do any of the top numbers and the bottom numbers share a number that I can divide by? And I see, oh yeah, 2 I can divide by 2. It gives me a 1. And I can divide this by 2 as well, and that also gives me a 1. So now this 1 times 1 is on top, and this 1 times 3 is in the bottom. So this gives me 1/3. This is called cross-reducing. Cross-reducing. Some of you might have done that before. It might be a little rusty. Any questions or comments on that before I go back to Kahoot? Okay, let's go back to Kahoot, finish that off. So okay, this is a good one. What is 5 times 3/5? Hint, think of 5 as 5/1. Let's do this one together. So I'm going to write this one as 5 times 3/5. Let me go to my, and here we go. Here are some extra ones, but we have 5 times, it was 3/5. And I'm going to write this as 5/1. I can always put a 1 in the denominator when I have a whole number. I can take any whole number and write it as a fraction by writing it over 1. And now I can I cross-reduce this? Someone give me a chat or a yes or a no. Can I cross-reduce this? Do you see something on the top and the bottom that crosses off? Yeah, those 5s basically knock each other out. These 5s actually, 5 divided by 5 gives me 1 and a 1. So now I have 3 times 1 is 3. And on the bottom, 1 times 1 is 1. And 3/1 is really just the whole number 3. I want you to look at this closely because this is going to help us a lot with what Bob is going to show you, I believe, tomorrow in class. And I won't be in class with you tomorrow, but turning denominators into 1s will help us for what Bob is doing tomorrow. And I'll come back and do some of these fractions with you if we have time today. But I want to show you that if we multiply, these two guys actually cancel each other out, leaving the denominator to be 1. So that's a seed I'm planting for you for tomorrow. Let's go back to Kahoot. Okay, let's see. I think I've got one more of those. Let's see if you can get it on this next one here. what is 9 times 2 over 3? Remember, write that as 9 over 1, and can you cross reduce? So I think whoever, yeah, so most of you got it. So whoever wrote 18 over 3, you are right. You are right. Whoever did 18 over 3, you are right. But what is 18 divided by 3? Maybe I should point this out. A fraction is really the same thing as 18. So in this class, we probably won't be writing it like this anymore. This is really fraction are really division. Is everyone able to see what I'm writing okay? Or not? Okay, I just want to switch the way I'm sharing it here. So fractions are really divisions. They're called rational numbers. That's what Bob was talking about before. Okay. So one more question for you. And this is the real kicker. It's yes or no. Would you be able to solve that equation? Yes, maybe, probably not, or no way. Be honest with me. That's kind of what I figured. A few people, yes, a few people maybe, and probably not no way. I want to get everybody to feel like yes, definitely at some point. I get the sense that some of you are really strong with this stuff, or maybe it's fresh, maybe you have this class recently, and some of you still have to work with this stuff a little bit more, and that's typical. I mean, I see that a lot. So what I want to do now is I want to open it up to questions, but I want to say, if you are super confident with what we've done with me the last hour, I'm gonna dismiss you in just a few minutes. But for those of you who are feeling a little bit anxious with this stuff, I want to encourage you to stay back and tell me what you want to work on so we can get you there. A lot of this stuff is simple. I just need to show you how these work so you feel more comfortable with it. And before that, where is my go away? I don't have it in here, but the study guide I'll make available. I'll put it under academic coaching, so under resources, academic coaching. And there's a study guide I'll put up here. You can download it, you can open it, you can print it if you want to. And basically, it's just another resource for you. For those of you who might be a little bit shaky yet, it has some extra examples, extra explanations. It's a good study guide, so when it comes time for tests, it's something you can look at to do some of the problems in here. All the answers are in the back, so this is just another resource for you if you want. Any questions for me before I say let's pause? Okay, so I'm going to say if you feel pretty rock solid comfortable with what went on today, please feel free to take off, bug out. I'll see you next Monday, same time. So Bob will have class and I'll work with you on a few things to get you ready for what's coming up. My pleasure, Evan. So for those of you, I know there's a couple of you who are still seem a little shaky. I want you to stay back and talk with me so we can figure out how to get you where we want you to go. So I'll give you a couple minutes to bug out, and have a great afternoon. Have a good day, Jace. So if you stay back, I want to make sure that you feel a little more comfortable. What was that question here? Let me open my chat again. Where do we go to see the homework for the day? Okay, good question. So let me go there. So for you, first of all, let me point this out. So on the calendar in Blackboard, I always go to the calendar to see what's due when. So here's today, Wednesday. Today, it looks like he's got the homework due on Saturday at midnight. So you've got until Saturday to do the homework. And he's got it here. He's got everything listed. It's your chapters 1.2, 1.3, 1.4, and then chapter 2.1, 2.2, 2.3. So after tomorrow, he should get through everything here and give you enough information to get that stuff done. So which means you have all day Friday. If you need help, let me know. To get to the homework, under class materials, you see student My Math Lab. You click on that, and right under all assignments, now open new window here. And here they all are. Here's 1.2, 1.3, 1.4, and then 1.2 or 2.1 and so on. Does that answer your question, Bryce? Or is it not?
I'll just talk, but I can't see the assignment part, the first one you clicked on, all assignments.
Oh, let me see here. Let me try it again. Let me go back.
So I just have math browser check the e-text and quizzes and tests, and then the math homework. Is that the one I click?
Yeah. So click on student. Let's see. Let me look here. I think it's student My Math Lab. Right? Student My Math Lab. Oh, I'm sorry, maybe under learning plans. Under learning plans, there we go. So under learning plans and learning plan 1, there they are. And then I think chapter 1, and here they are. Here's 1.1. So it's a lot of clicks to get there. Where's the homework, dude? Uh, 1.2. Here we go. Here it is. Did you find it now, Bryce? Or do you need me to go back and do it again?
I'm getting there. Hold on.
All right.
1.2, right?
1.2 is the first one, yeah.
Okay, yeah, I see it then.
So yeah, it's kind of a rabbit hole, but once you get the hang of it.
Yeah, okay. Then I'm all good then.
All right, cool. So person and I'm gonna say this right. Azil? Can I help you? Let's look at some fractions. So what are you thinking? What are you feeling about these fraction things here? Come on. LCDs. And you can unmute yourself so we can just chat freely. It's just us three. So feel free to let me know so I can review some things with you. What would you like to do? Should we find some common denominators? Carson, how do you feel about finding common denominator LCDs?
Very good.
Very good. How about you, Azale?
I'm feeling good about that.
Okay. What else was there? Was it the multiplying or reducing?
I was just looking along at just recatching on what you were doing.
Okay. Because you know, a few people were getting some of the things wrong. So I want to make sure everyone's comfortable with what we're talking about. And if there's anything that you're thinking, boy, I'm not quite catching that yet, let me know. How about the multiplying fractions?
I'm doing great on that too.
What about Azale?
Same here.
Doing great on that? So if I ask you, let me ask you this. You're gonna get a sneak peek here. I'm gonna go in my study guide here. I'm just scrolling down. Where is it here? Let me go here. What about solving equations? How do you feel about solving equations like this?
Yeah, I understand that completely too.
Okay, Azale?
Same here.
What about, did either one of you answer no way when I asked you if you can solve these problems?
No, I answered yes, definitely.
How about Azale?
I said yeah, but give it some time.
Okay. The people that gave me the no must have bugged out, which is unfortunate because I wanted to stay back and help them too. So I can show you as long as you're here if you want any tips about how to do these. So there's a couple of things combined into one when we do this. So I always say these fractions put people off. They don't like these fractions. And I always say whenever we have an equation like this with fractions, we can always get rid of those fractions. My first question to people is, well, let me ask Carson, do you know what the first step would be to solving this number one?
Yeah, get a common denominator on the bottom of all of them.
Actually, that's partially true. I'm going to say I don't want to get I want the denominators to all be one.
Okay, so do you want to move your x over?
Not yet, but that's good thinking. But I want to clear all the denominators. And how am I going to do that? What is the
You
least
can just take 5x and then you multiply. So it'd be 5x minus 6 equals 14.
Yeah, and you do that in your head. How did you get those numbers? Because Izale, I keep saying her name wrong. I know it. I'm sorry. Izale and I are wondering how you got that. And you're right, but how did you get that 5x minus 6 equals 14?
Just looked at the denominators on the bottom and I found the lowest common denominator is 4.
Yeah, so the LCD, I always say this.
And then
the LCD,
to get the other ones to 4, you have to multiply by 2.
So we're going to multiply everything by that LCD. So we have to distribute. So when I multiply this guy, this 4 and this 4 cancel, leaving you that 5x you said, right?
Yep.
Now I distribute this to this guy. This 4 and this 2 cross reduce, giving me a 1 in the bottom and a 2 here. So 2 times that 3 gives me a 6. And the same thing happens with that 7 over 2, right? This 2 cancels with that 4 when I distribute it in, giving me a 2 here. 2 times 7 is 14. So that's how you get rid of those. So it sounds like, Carson, you feel pretty comfortable with that. Azale, am I still saying your name right?
No, you're butchering it.
Oh, what is it? I'm sorry.
It's Ezel.
Ezel.
Yeah.
Ezel. Okay, like easel, but the emphasis on the second syllable. Ezel. Or first, Ezel. I'll get it. Ezel. Okay, Ezel. Does this help with these problems with the clearing the denominators?
Yeah.
Absolutely.
Okay. because that's going to be that's a major stumbling block for a lot of students. And this skill will come back again much later in the class when we talk about rational expressions, which we don't just have numbers in here. We've got a whole bunch of letters and polynomials all over the place, which looks like hell, but we can make it much simpler by clearing out denominators like this. So for like number 2, what would be the least common denominator for number 2?
6.
6, yeah, it's 6, 3, 2. So this is going to give me a 7x. 6 divided by 3 is 2. Times that 1, it gives me 2. 6 divided by 2 over here gives me a 3. Times that 1 gives me a 3. That x is still there. 6 divided by 3 is 2. Times that 5 gives me a 10. And then going back to this first one up here, I would add 6 to both sides. Gives me a 5x equals 14 plus 6 is 20. Then divide by 5. Is this coming back for each of you?
Yeah.
Oh yeah, I just got right out of high school.
Oh, okay, good. So if you can do this, then you're in good shape, I think, for what's coming in class. Perfect. Is there anything at all that either one of you is concerned about at this point?
Not really.
All right.
Same here.
Cool. Well, then I'll let you go and get at it. If you do have any questions about anything, feel free to reach out to Bob or me. I'm sure we'll get a little bit more challenging problems in here, but just keep up and we'll be good to go.
Awesome.
All right. Take care.
Yep.
You too. I got a question for you.
Yeah.
You used to work at Plexus, right?
Yes,
Did you know a guy named Jim Hurst?
I did. Yeah,
That's
he's a
my mom's
software
fiance.
engineer. Oh, is it really?
Yeah,
Joe Hurst. Is he a software?
he's electrical engineer.
Yeah, electrical engineer Joe Hurst. I'll have to look him up. I've worked there since 2005, but I do know who he is.
And my dad actually used to work there right when he got out of college.
Okay, what was his name?
Rich Andreas, he was a plant manager.
That name sounds familiar. I wouldn't have known him because I worked for the design part where Joe Hurst
Okay.
works. Joe Hurst. Yeah, I'll have to look him up because there's a couple different Joes.
Yeah.
It's been so long, but okay. I was just trying to think. I thought Joe Hurst was married, but he could have been divorced since then, and he's dating
Yeah,
a
he
mom
got
now.
divorced, and then those two just got engaged like 2 years ago, 3 years ago.
Okay. Okay. Wow, it's a small world.
Yeah, it really is.
So what kind of engineering are you thinking about going into?
I was thinking packaging or
Packaging.
plastics,
Okay. Yeah,
but
and that's
I was kind of on the fence about architectural.
yeah. So I as I said, I was a mechanical engineer, and working at Plexus, at least at that time, a lot of the design work we did was plastic part design. And then I worked for a small company down in Sun Prairie, and we also did a lot of plastic part design. So for me, it was the engineering degree, and I know some colleges will have a lot of classes that focus on plastic design, plastic part design, and so if that's something that you're interested in, that's something to definitely look for.
Yeah, I know because Stout was just dumping a bunch of money into their engineering a little while ago, and now they have like specific classes for engineering, like a plastic specific engineering class.
Yeah, and that's a big deal. A lot, because a lot of electronics are in plastic housings, and so they
Exactly.
need. Yep. And then
And packaging as well.
yeah, when you say packaging, I'm assuming you mean electronics packaging, like packaging electronics, such as your phone, your cell phone is a packaged design.
Yeah, it could be that, or either like the actual packaging of items. Like my dad has a buddy who works for Sub-Zero and Wolf Appliances.
Yep.
And he's a packaging engineer for them, and they do like testing on like the packaging of their refrigerators and stuff. Like they'll push them off loading docks, see what happens to them, see how they can improve it.
Oh, sure. Yeah, whatever sparks your interest, definitely go for that. Yeah, that's cool. And when you start doing internships, that's a good time to see if you like those careers as well.
Yeah.
Cool. Well,
Awesome.
you're gonna definitely want to be good at this math stuff, because I know you probably have to take college algebra or pre-calculus after this.
Yep.
And calculus, and I've taught calculus, and it's funny that most students that struggle in calculus struggle the most with just this algebra stuff. So,
oh really?
Yeah, if you can lay a good foundation as algebra, this class and then your next algebra class, the calculus itself should be much easier.
Yeah, I just find all this stuff really easy. Like it just comes natural.
Yeah, I was the same way. I not everybody's like that, but some people just pick up on this stuff pretty quick. So cool. That's exciting.
Yeah, we'll catch you
Awesome.
next class then.
Will do. I'll see you on Monday. You'll have
All
class tomorrow, but I'll catch you on Monday. If
All
not,
right, sounds good.
have a great weekend, man.
Thanks, you too.
Take care.
You too. Bye.